Okay. Ladies and gentlemen, we are from Algoria. My name's Alfie. This is my colleague Jeremy. Yesterday we were debating who would do this talk, and I lost that debate clearly, yeah? So no, I'm doing the talk today. So AI is revolutionizing the way that we use search, and what we want to do today is talk a little bit about neural search and how Algoria is combating that. So let me change this. As I'm sure lots of you are aware, search and discovery has been driving e-commerce revenue forward for decades. We now see that nearly 50% of all people who visit websites go straight to the search bar, and those that do are 3 times more likely to convert. Even Amazon is stating that nearly $1 billion in monthly incremental revenue comes from continually investing in search. So the impact in search is very clear. The numbers speak for themselves, but there is still a lot of improvement that we can do. So the challenge we see with current basic search solutions is that there is a huge amount of optimization that's required, a huge amount of manual effort. And that often means that there are lots and lots of terms that are left completely unoptimized. The only way to solve this is to have a fully automated solution. Otherwise, we're still stuck with all of that manual effort. Now, the good news is that this is changing extremely rapidly. We're seeing that the market is having to shift extremely quickly. We're seeing the average query length more than double from 2.6 to 6.8 words. And there is this expectation that websites deliver the perfect Netflix experience. Now, this is extremely difficult to do because 70% of customer queries sit within what we call the long tail of search. And I'll explain what that means in a minute. I can see that you're all really interested to know what long tail means. So we've seen the likes of Siri, we've seen the likes of Alexa being used, but there are new AI technologies coming out every day that just revolutionize the way that we engage with data. Now, what's really exciting for Algolia and Algolia's partners, Columbus, is that at their core, those new technologies are just search engines. And that means that search is really now the forefront of AI. And for many companies, that is the first way that they can adopt AI, and if they want to take advantage of this. So we see a shift in the market. The shift is moving away from matching and moving to true language understanding. And the really exciting thing about that is that it's the user that no longer bears the burden of search. And I'm sure you've all experienced that. You've gone onto a website, you've tried to look for something, but you don't actually understand or you don't know the term that you need to use to find something. It is now the search engine that should adapt to its users. And that's what's so compelling about this change. And it might seem like this change is happening really quickly, but it's actually been around for a very long time. It's been around since the 50s. When we say matching, we mean keyword matching. Bear with me. It's been around since the 50s. It's been around since we've had computers. That's because it's quick, it's reliable, and most importantly, it's scaled for speed. And then but the challenge with keyword matching is it's still limited to just the query and the data set. Yeah, it's very limited. It doesn't actually understand what the user means. It doesn't understand the intent. Over the last decade, the new cool kid on the block has come along, vectors. Vectors offer a new underlying technology for search. They bridge that gap between matching and understanding. But the challenge with vectors is they're extremely resource intensive, very expensive, and very slow to run. But they're a bit of a buzzword. Why is everybody talking about them? And this is, I've gone a slide too far. He's taken slide, one sec. There we go. Sorry, we had a slide in the wrong place. So, vectors, what are they? Why is everybody talking about vectors? Woo, vectors! Vectors are really, really exciting. They take tens of millions of data points, and they turn them into a multi-dimensional map of ideas, and the distance between those ideas is based on how closely related they are. Now, we use the term a 3D map, but it's actually a 512-dimensional map of ideas. It's very difficult to get your head around. It's too much for me to understand. When a user searches when a user searches, this is why we got Jeremy here, because he's very technical, he understands computers. Here we go. When a user searches, like a term here, pullover, the query is converted into a vector. It's then put onto that map of ideas. The search engine then pulls back the closest set of ideas and allows us to view that term as much more of a cluster of ideas rather than a collection of letters. Now, this is a very human way of thinking. We think in terms of ideas and phrases. We don't think in individual characters. This is what keyword search returns to us. Now, this is the key to harnessing and unlocking that long tail of search. Now, you're probably thinking, what on earth is he talking about? Why does he keep saying the long tail of search? This is the long tail of search. This is the 70% of all customer queries that sit within this long tail. Individually, they aren't searched very often, but as a whole, they represent 70% of all queries that customers make. Keyword search, historically, has been fantastic for helping with understanding those very regular and common terms that we see. Red shoes, black dress. But as we move further down the tail, queries become longer, more nuanced, more complex. It's extremely manually intensive to put rules and synonyms in place to understand these complex queries. Things like, what should I wear for my 30th birthday party? Sparkly pink Barbie dress. How do I keep my beer cold outside? If we don't have relevant results for these queries, we're leaving a huge amount of revenue on the table. Now, at Algolia, we see that if you can optimize this 70% of queries, there is up to 30% in additional revenue. Now, imagine if we can give our customers an additional 30% in revenue. Fantastic. Oh, wrong thing. Last slide. So why isn't everybody using vectors? Well, they're incredibly expensive. They're incredibly difficult to store. We go back to that slide we had earlier. Here we go. And what Algolia has basically done, in a nutshell, we bought a company that allowed us to compress vectors. We took them from big, we made them small, and we call that neural hashing. It allows us to use vectors at scale, at speed, and provide relevance. We're the only company that can do that. That's the core of our innovation, and that's what allows us to basically create what's called, and we go back to this slide, bear with me, neural search. This is the combination of keyword search and true natural language understanding, all within one API. And that would have been smoother if we had the slides in the right way. Drum roll, Algolia Neural Search, the first end-to-end AI search engine that understands conversational search queries. Now, the best way for us to show that to you is to actually get Jeremy to do a live example. You can actually see how this works, the actual magic. Thank you, Jeremy.
Thank you very much, Alfie. So let me quickly move to the new interface. Take 1 second. There you go. So we created a demo to actually showcase the impact of neural search on different type of queries, from fathead to long tail queries. And so we're going to start with a very simple query here, which is dress shirt for office job. And so what I'm actually looking for here is I'm looking for a new shirt for my new job that I'm starting next week. And as you can see here on the keyword setup, I actually don't find anything. Why is that? Because the keyword is actually not really matching the query in itself. So what we can do is we can actually now move to the neural setup, and we can see that with this new engine, with this new notion of vectors that we're actually trying to understand the intent of the query in itself, we're capable of finding the right type of results for the request that I was actually making in the first place. So I'm really looking for a new shirt that is a professional shirt for the new job, and that's what the engine was actually capable of finding in the first place. Another example that I quite like as well is this notion of small USB. So let me go back to the main search. Here I'm going to search for small USB. And as you can see here, what we actually see is that I only have one item that is being returned. Why is that? Because we actually match within the result set. We match the word that is the word USB within the title. But the problem is when I'm searching for small USB, my intent is looking for a small USB key that I can plug into my laptop. So if I move to neural search again, this time, I'm actually going to increase the recall of my data set. And so I can see here that I have one result for keyword, and I have plenty of other results for the vector engine. And so if I scroll down a bit more, I can see here 2 items two small USB keys that I can actually plug into my laptop, and that's exactly what I was looking for in the first place. So the engine was capable of understanding the intent of my query. The last one that I also want to mention here is the fact that with neural search, we completely remove the need for manual interactions with queries, so no need for synonyms or for rules in itself. And so what I'm going to be doing here is I'm going to search for TV gift cards. I'm going to quickly search for this here. And so what we see on the keyword setup, I can see Netflix and iTunes type of cards. If I move to a neural search, what we're going to see is the results will be a bit better because I'm really matching on the intent once again, which is all about TV. So Hulu is a lot more related to TV than iTunes, which is once again a better type of results than if I was only looking at a keyword engine. But on top of this, what is quite interesting here is that I'm going to go back to keyword just for the sake of it. I'm going to replace TV by telly, which is a British slang for television. And by default, on my keyword setup, I'm actually not finding anything. Why? Because I don't have telly in my data set. However, if I move to neural search, the engine will be capable of automatically finding these Netflix, Fandango, or even AMC, which are movie theaters, type of gift cards. Why is that? Because the model that we're using behind the scenes is actually understanding the concept of telly, which is very close in the cluster of ideas that Alfie was mentioning, all about the TV, all about the notion of movie theaters, and so that's how we're capable of showing this type of results at the end of the day. So with neural search, we're capable of increasing the recall, getting more results for the type of query that we're looking for, understanding the intent of the query. So even if we don't have results in the first place, the engine will be capable of understanding what we're really looking for behind the scenes. And the third one is removing the need for manual interactions or manual curations of queries by removing the need for synonyms or removing the need for automatic ranking of results based on what the engine is capable of understanding in the first place.